Hello everyone, welcome to DSQL. My name is Dinesh Priyankara, Microsoft MVP and IT consultant. Today I want to talk about something new, not entirely new since it was introduced about 6 months ago and still in preview, but definitely worth checking out. So this is called Native Execution Engine for Spark, which is available in Microsoft Fabric, and it's all about improving performance, specifically for data processing and reading. So right now, this feature isn't enabled by default. You will need to turn it on manually to test it out. So you have to actually create an environment, and then this has to be enabled in that environment in order to use it. And that's exactly what I did. And I ran it in an environment with billions of records and heavy complex data processing to see how well it performs. And honestly, the results were pretty impressive. So in this video, I'll quickly walk you through what this engine does, and then we look at some codes that's similar to what I tested in client's environment. I cannot show the exact code I used because that was tested in client's Fabric account, but now this should give you a good idea of how it works and the kind of performance boost you can expect. So let's get started. Okay, what is native execution engine? So consider this is as an enhancement on traditional Spark execution engine. So this improves the performance of data processing, data reading, and you don't need to make any changes to your code. You can simply take your code and then run it in an environment, which is native execution engine enable environment. Okay, and then you should see some performance improvements. All right. So this is really good for, this is what I have experienced. This is really good for ETLs or the batch jobs, data science experiments. But in certain cases, I did not see the performance improvement. Actually, I did not see, even though the code has been executed in an environment, which is native execution engine enable environment, it does not use all these new components. So which mean, that code really not suitable for this. So you have to make sure that, your code is, really ready for this native execution engine. All right. So how do you start? You have to create an environment. I'm sure that everyone knows how to create an environment. I'll quickly show you the way of creating an environment, and then you have to go and enable this. So once it is enabled, then you can use that environment with your job definitions or your notebook codes. That's how you start. Okay, right. You need to make sure you use Fabric Runtime 1.3, which has Spark 3.5, right? If I'm not mistaken, this was enabled for previous runtimes, but now it is not. So make sure the environment is configured with runtime 1.3. Okay. This does not work with all type of formats. This works with Delta tables and then Parquet files. I did a test on Parquet files, and that's what you're going to see. Okay, but if you have Delta tables, yes, you are going to see some improvements. So how this has been formed? This is based on two key open source software components. One is Velox, another one is Apache Gluten. That's what you see with this illustration. Okay. So we don't need to go into details, but let's try to understand this. So what is Velox? So it is an open source C++ database acceleration library. This was introduced by Meta. And why we have to use, or what it does is basically it optimizes query execution by providing efficient vectorized in-memory processing for analytical workloads. Now we know that when it's come to DeltaTable and Parquet based data sets, what you have is columnar format. So which means those formats are really good for what? Analytics. So when you work with analytical workloads, Velox works really, really well. Okay. So what is Apache Gluten? So Apache Gluten is something that can be used for connecting two different components. Okay. So one is JVM based SQL engine, and then the next one is Velox. So we need to have some sort of component sitting in between these two for handling the communication. So it's basically, you can consider it as a middle layer. right? So it's a middle layer that bridges these two components. So when it's come to Spark, it is a JVM based SQL engine. Okay, so if you want to make sure these two communicates really well, then you can use something like Gluten. All right, so that's why we see Gluten with this native execution engine. So what it does is basically so the Gluten offloads the workload or the execution from JVM to Velox. Okay, that's what we see with this setting. Now, for example, as you see in this illustration, let's say you make a request. Okay, let's say it's a Python code. It's in Fabric notebook. Okay, so when Fabric execute the query, if the environment is native execution engine enabled, okay, then it bypasses the traditional Spark execution engine or the model, right? So it goes through the Gluten. So Gluten simply intercept the Spark SQL execution, and then it offloads that execution to the Velox. That's what we see with this setting, right? There are many more things related to this engine, but we don't need to go into that level, right? If you want, I hope you understood how it works and all right? So this works with your data in one lake, right? So you'll be having DeltaTable, Parquet files, data warehouse tables, okay? So everything is in one lake. So if your data is in one lake and environment is configured with this, then you will see, Gluten and Velox usage, okay? And this works with shortcuts as well. So let's say you have an Azure data lake, storage, and then you have created a shortcut against that, and you see the data in your Fabric, but the reality is basically data is in Azure Data Lake. Okay, but the good thing with Fabric is, if you are, let's say, processing some data in your Azure Data Lake in an environment where you see native execution engine enable, then you will see the usage of Velox. Okay, all right. And this can be simply configured at the workspace level. That's what we normally do. But if you want, you can configure at the notebook level and the cell level as well. Now, why you have to go for cell level? The reason is, let's say you have a notebook with multiple cells and one cell contain a set of codes, and which is not really good for native execution engine. But the second cell contains a code, and you believe that it will benefit from native execution engine. So in that case, what you do is, when it's come to the second cell, you have a Spark configuration statement. I hope everyone knows how to set the Spark context. Okay, so you use the same spark.conf.set. Okay, you use the same statement for enabling it for that cell only. Okay, and then you get the code executed, and you can again disable it. Okay, so making sure you are going to use native execution engine only for that cell, right? Currently, you are not going to see any charges on native execution engine usage. I'm not too sure whether Microsoft will charge you, or there will be an additional charge on this, but it looks like there will be an additional charge on this, but currently no charges. Okay, you'll be seeing zero amount or zero cost. Okay, there are a couple of limitations on this. For example, let's say your code performs merge operation. Okay, so in that case, it is not going to use these specific components. Okay, if you have user defined functions or arrays or array related functions, then you will not see Velox components as a part of your code execution. Likewise, there are set of limitation. I have shared the Microsoft Docs link, so that has all the limitation listed. So just go through that page and try to understand all the limitations. And how do we really check whether your code has gone through this native execution engine or not? Now, let's say you have a code, you execute the code, right? And you are executing it in an environment where native execution engine is enabled, right? But how do you really know whether it goes through a native execution engine, or it goes through standard traditional Spark execution. So there are a couple of mechanisms or methods to check. One easiest way is you just check the jobs and the stages of your Spark code execution. If you see something like native file scan, Velox, or some sort of transformer suffix, okay, it means native execution engine has been used, right? If you do not see those things, which mean it has not gone through native execution engine, right? So you can expand the job context and then see the stages. Okay, if you want to see details, you can open the standard Spark dashboard. Okay, and then see something like what do you call DAG visualization. Okay, you can open it and see, or else you can use the explain function. Okay, you can use the explain function. So explain function also shows whether this has gone through native execution engine or not. All right, I think explanation is enough. I'm going to take you through a code. So let's execute that code in standard environment or the default environment, and then let's execute it in native execution engine enable environment and see whether we see some performance improvement. Okay, so let me open my Fabric account. Okay, so this is the test workspace I created, Fabric test 010. So you can see a couple of Fabric items. You can see an environment and then a lake house and a couple of notebooks. Okay, I have already written code, so let me take you through notebook codes. But before that, in order to make sure that we use native execution engine, you must have an environment. So how do you create an environment? Click on new item. Let me quickly show you new item and then search for environment. Okay, so you click on the environment and then get the interface open. Let me open the one I have already created. Okay, so you can see the standard libraries, Java, Scala, Python libraries and all. But if you want to enable native execution engine, you have to go for acceleration page, and then you need to select this checkbox. Okay, so I have already done it. So this, if I use this environment, then it will try to use the native execution engine. Okay, let me go back to my workspace. All right, this notebook shows two tables I have created. So the first one, not exactly tables, I have two folders, sales and products. You can see the first folder contains somewhere around 1.6 billion records, and second table contains somewhere around 5 million records. These are the two tables I'm going to use for testing this. And the data set, you don't need to worry about these values. Okay, all these values are generated through a sort of a code. Okay, these are not real sales or real products. So you can see, sales data, sales ID, product ID, and the amount, quantity, and the sales date. And then product table, it has product ID, category, and the brand. Okay, so these are the two tables I'm going to use for this testing. All right, this demo code. The first cell basically shows you the way of enabling native execution engine for your notebook. If you are going to use the environment you have configured, you don't need to do this. But let's say you have not configured any environment, but still you want to use native execution engine with your notebook, then the first cell, that's what you have to use. Okay. But let's say you want to enable this at cell level. In that case, you have to set the Spark context. Okay, so you have to say spark.native.enable true. If you want to disable it, you set it as false. All right. Okay. So let's do this with the default environment. So you can see if I go to Home tab, this is the workspace default. So which means I'm not going to use the environment with native execution engine. Okay, this is the default environment. Let's do, I have two types of codes. Okay, the first code is, as you see, I read the sales folder into sales df, and then I create a weave, and then I execute a select statement. Basically, I'm trying to get the count based on a product ID. All right, it's a very simple one. Then I call the collect to make sure everything is getting loaded to the row object. And then let's have a look on the explain command or the explain output. Okay, right. So let me execute this one. I have already executed this just to make sure that everything works well. So I'm going to execute it again. So let's see how long it takes. All right, it got executed. You can see 36 seconds. So how do I know whether it has gone through native execution engine or not? I can go through this details and see, but I don't see anything like native scan or Velox usage or transform a keyword. I don't see anything. So which means it has not gone through native execution engine, right? Okay, so let's execute the same code in the other environment or the one we created. So let me go to home and show you. So you can see the environment has been set. All right. So I'm going to execute the same code. Let's see the time and then let's go through the detail, and see whether we see those keywords. So it is being executed. All right. So within 9 seconds, we got the result. If I go back to my previous code, you can see it took somewhere around 30 seconds or 35 seconds. But here within 9 seconds, we saw the result. As you see, we can see Velox columnar row execution. We can see that keyword, and you can see native file scan, as a part of this explain output. So which mean, this code has gone through the native execution engine, and because of that, we see some good performance. All right. Let's execute the other code as well, which is a bit complex than the one we just executed. So let me go back to the previous notebook, and this is the code. So what I'm going to do is I'm going to load both tables, and then you can see I try to record the time as well. That's why you see start time. Okay, and then I load the product table. You can see I have used broadcast. In certain cases, if we have used this one, then we see native execution engine usage. All right, and then what I do is I load product table and the sales table, and then I join and perform some aggregation. Okay, that's based on category and brand, and then I do something similar again. I load the sales and product, but this time we group it by category only, and then after that I use union for combining these two results. Okay, so let's execute this and see. So earlier you can see I have executed. This has taken about 2 minutes and 49 seconds, but let's execute this and see. All right, code is completed. You can see it has taken about 2 minutes and 44 seconds, but the execution time based on the start time and the end time for data processing, it is somewhere around 158 seconds. Okay, let me execute this code to see the details. If I scroll down, I don't see anything related to a native execution engine. Okay, so you can see file scan, you can see hash aggregate. I don't see anything like transformer, Velox, or native file scan, nothing. All right. In addition to that, you can expand Spark jobs and then go through these jobs and stages, but we don't see anything related to native execution engine. All right. So don't worry about this result set. Okay, this is all about just going through two tables, perform some aggregation and grouping. So let's go to the other notebook. I have the same code, so I'm going to execute it. So if I scroll down, you can see the previous execution. It has taken somewhere around 1 minute and 4 seconds. This, it is almost 3 minutes, but this one, somewhere around 1 minute. But let's run it. Let's run it again and see. So I'm going to execute this cell. All right, we can see the result within almost 1 minute. If I scroll down, we can see the exact execution time. So that is 71 seconds. So the previous one, that is somewhere around 158 seconds. So we can really see some improvements, when it comes to data processing or this type of data reading. Let's go through the explain output and see. Now with this, I don't see anything like native file scan or something like Velox. I don't see anything. Okay, but if I expand Spark jobs, you can see these jobs. If you look at the job 47, it says Velox Spark plan, right? And you can see the same with 46, and you can see 45, 44. You can see the Velox keyword. So which mean this code has gone through native execution engine, not at all stages. All right, but still we see good performance with this environment. But sometimes when I perform, let's say I'm trying to get some data out with some aggregation, but no joins and all, I have noticed that we don't see much differences between native execution engine enable environment and the standard environment. Okay, so you really have to check and see whether your code goes through native execution engine, and then you see some performance improvements as well. Okay, at this moment everything is free, but if Microsoft starts charging you, then do not go for native execution engine unless you see this benefit. Okay, but anyway, with these two examples, we can clearly see that this improves the performance of data processing and data reading. All right, that's all I wanted to show you. I hope you saw the value of native execution engine. Remember, it is still in public preview, but worth to try and see, right? Specifically, if you are working with large data set, I don't think that you will see any benefits if you work with something like a small data set. Even Microsoft says that this is good for large data set, not for small data sets. All right. So if you test this and then if you see some significant difference in terms of the performance, please share your experience. Add a comment. Just let us know what you saw with your code, right? That will be really helpful for me and others as well. All right, that's all from my end. Thanks for watching.